Hello, everyone. My name is Rayees Pasha. Welcome to Streaming Stories, episode 5. So the title of the today's webinar is RisingWave, a look back at our journey to build distributed SQL streaming database. Today's session will all be about RisingWave. We crossed a few milestones recently, so we decided it'll be a good time for us to celebrate with the community. As part of the celebration, we are going to have a raffle to pick prizes. We thought initially we'll pick winners from the raffle, but then I figured, since this is a community event, we want to celebrate. We will be sending swag to everyone who attended the webinar, and so stay tuned for that. Some housekeeping items to start with. You probably are aware we're using Zoom webinar. We have muted the attendee line, but that doesn't mean you don't get to ask questions. We welcome questions, and we encourage you to use the Q&A tab at the bottom to post questions, and we'll answer them as we can during, and at the end we'll leave some time for any questions that didn't get answered. And the webinar is being recorded, and we will email you a link to the recording as well as the slides that are presented today. And finally, if you have any issues with Zoom, please contact the organizer via the chat. You can post a question if you're having difficulties, audio or any other issues. Feel free to reach out to the moderator. Okay, so first the introductions. For today's presentation, both of us, the presenters, are from RisingWave Labs. My name is Rayees Pasha, and I head the product team here at RisingWave Labs. A little bit of my background. I'm primarily I started out as a developer on the database management side. I worked on the optimizer on a SQL-based system, and then I transitioned to a product management role. I've held PM roles at different companies. Most recently at Tygraph. Prior to that, I was at Workday, Hitachi, and HP. And as a practitioner of database and data platforms in general, I've seen all the trends that have happened over the past 2 decades, and I feel like RisingWave is again is at an inflection point for stream processing, where we're building something truly unique, and I'm really excited about the market need we're trying to fill. I have a master's in computer science from University of Memphis. Joining me on the webinar is Xiangyu Hu. He's our head of engineering on the cloud team. I'd let Samuel introduce himself.
Thank you, Rayees. Hey, everyone. My name is Samuel. I'm the GM and the leader of the cloud engineering at RisingWave Labs. Before joining this company, I spent most of my career also in systems, databases, and cloud technologies. And I used to work at Microsoft Azure Data, SQL Server, and open source databases. Also, I worked on the project called GaussDB, RDBMS, as well. So most of my career has been related to databases and systems.
All right. Thank you, Samuel. All right, so let's look at a quick look at the agenda we have for today. As I mentioned, we're going to cover different aspects of RisingWave company, the products we have, and most importantly, the recent RisingWave Cloud beta announcement. So we'll start with the beta announcement first. I'll give a quick overview of the feature overview of key areas of the RisingWave Cloud product. Then I want to spend some time to highlight our journey so far as a RisingWave Labs company. What are our guiding principles? What are the core value we're bringing to the market? And also, I want to emphasize our role in the community. We are an open source database. So what and how have we grown on the community side? I'm going to spend some time. Then I'll turn it over to Samuel to provide a technical deep dive on our cloud product, and also to share a little bit about the use cases that are a good fit for us, and especially one use case of an actual customer deployment, and how RisingWave helped the customer. And then finally, we'll wrap up the webinar with our demo. We have a great demo. It's a two-part demo. One, I'll kick it off with a quick overview of the functionality of the cloud product. And then Samuel will walk us through an application use case and showcase how RisingWave makes it really easy to build a real-time stream processing application. Please do stick around for that exciting demo. Okay, so now for the marquee announcement, the key thing that I know some of you who follow us on social media probably are aware that we launched RisingWave Cloud beta release last week, and we're incredibly happy, proud about that. And I want to give some context behind it, right? Before I share more details about the features, why this is important, because stream processing, like I said, is at an inflection point where more and more businesses are taking to use stream processing to further their business and use to push for new use cases. Now, the challenge is, as they do that, they run into complexities of hosting and running the services and all that. And unfortunately, the market doesn't have too many options. Since it's still a nascent field, that's where RisingWave Cloud, I think, comes in. It has a place in the marketplace where we can, like our mantra is, make it simple, make it cost effective, so that you don't have to build, you don't have to maintain. And from that perspective, on that journey, this is the important milestone. I know it's a beta release, but still, we feel like we've come a long way from where we were 6 months back when we had unveiled the private preview product. Now, as we made the announcement, we also invited others to participate in that beta. We have a solid design partner program that gives you dedicated support, and we work with you closely to understand your business goals and see how a product can finish. And if you're interested, do reach out to me, and I can share more details on what that program means. But again, this is a significant departure from alpha to beta, and if you had looked at it at the private preview stage, I want you to give us another chance and look at our product. A little bit more detail on what the beta release encapsulates, right? So before I go into details, I want to go back to our vision. Our vision as a company is to democratize stream processing, right? We believe that the stream processing cannot be just the preserve of a few large big tech companies. And with that goal in mind, we have built cloud product, targeting a design for all enterprises of all sizes, small, medium, large, and also the developers, varying degrees of expertise. They could be brand new to stream processing, or could be advanced users. It could be even business users who do not really want to use SQL. They want to at a high level look at the platform, right? So from that perspective, we really design the platform with no preconceived notion that it has to be a certain persona. So it's applicable for different developer types. And the cloud product blends the fast maturing RisingWave database. It uses the same database. There's no different version. It's the same. All the power of the RisingWave database that's in the open source is available through RisingWave Cloud. So if you're a user or a customer who's familiar with the unparalleled scale, the cost efficiency that's in the database side, you will get those benefits out of the box automatically. And obviously, on the plus side, you don't have to worry about configuration management, maintaining the services, all that, right? So again, as we march towards the GA version that we have planned for the middle of the year, I invite everyone. And if you are a data enthusiast, you are a developer or a business leader, anybody who wants to transform their data platform, move from, say, for example, batch to a stream processing model, this is the easy on-ramp. You don't have to worry about setting up things and all that. This is a ready-to-use platform, and I really would like you to join us on this exciting journey. So let's talk about what is the value, right? We made the case that you want to join. So I want to highlight three aspects in terms of the value we generate. It's a fully managed service, so we've taken the approach of a solution as a hosted service. We want to give all of the functionality that is needed by developers, as well as the administrators in one single solution package. We've looked at all the 360-degree view of what requirements are needed to run a service, a streaming service, and incorporated all the functionality and tooling that's needed to build it. The second thing is the user experience, right? So RisingWave, the beta version is a brand new implementation. You may have looked at our product in private preview. From a UX perspective, you would see that there's a big difference. We've gone ahead and implemented user flows based on feedback we received from the private preview users, and also working closely with our design partners to make sure that everything is intuitive, from all the way from you get started, setting up clusters, to allow creating users, to ability to run a build application. And then the last thing is, again, I know people don't want to talk about cost of the product, but it is the elephant in the room, right? How does that help a business lower the cost? So RisingWave Cloud is the design. One of the core design principle is to keep costs under control, right? One of the things we have done with our cloud native design is the same principle that are after the RisingWave Database. The resources are only used when needed. So from that perspective, whatever cost that a customer incurs will be based on your usage. And obviously, the fact that we are Postgres compatible, all of these things further add to the overall costs that are required from a resource developer experience perspective. So how do you get started on the beta process, right? So we have simplified the process very easily. Like I said, there's no gating. No, it's a very simple sign-up process. You go to risingwave.com cloud. You give us your basic information for us to sign you up. You'll receive an email with a link to the RisingWave Cloud portal. As simple as that. There are no whitelisting. There's nothing where we pre-screen you or anything like that. We want anybody, like I said, everybody to come try our product. And it's not just about the sign up, but also we want you to learn and do at your own pace. So we know that you have a job, you have other commitments. So we have extensive documentation resources that are available within the product itself in the cloud with useful links, so that you can get started without having to go and look at documentation. And the cloud portal itself comes with a quick start guide, has a sample queries. All those things, the first few steps that you take can be challenging, and we've kept that in mind for new users. And then finally, proactive help, right? Like if you get into run issue, how do we do? We have a dedicated engineering support for the beta users. We have an email cloud beta at RisingWave Labs. So if you have any questions, either on the initial setup or during the usage, you could reach out to us. And with the cloud beta, everybody gets a free tier cluster. But if you want something big, you have a clearly identified use case that requires resources beyond free tier, you could of course reach out to us at sales@risingwavelabs.com, and we'll be happy to set up a custom cluster that fits your needs. So let me go over the feature overview, right? Like going through all of the features will not be possible because of time constraints. So I'm going to focus on 3 feature areas, the 3 parts of the cloud product that and of course there's a lot of details within each, but I'm going to keep it fairly high level. So I'll start with the workspace, right? This is the landing page that kind of incorporates all of the key functionality in one place. It's a single pane of glass, and it's been designed to keep new users in mind. Everything that's needed to get started available is on the same screen. We have a quick start guide, like I said, that allows you to go through the simple steps, like create a cluster, connect to the cluster through a client, create a data source, create a materialize view, run queries. So in a way, it's very broken down in a very intuitive way, so that you don't have to go and figure out things on your own. And then there's a ton of documentation at the bottom where you can learn, explore as you play with the platform. And then there's 2 key additional resources that we make available. One is the user guide. that tells you, like I said, 5-step process. And then we have another thing called playground. This is a pre-provisioned cluster. It has a existing schema and some sample queries. So even if you don't want to start your own cluster, you could use that pre-provisioned cluster with that existing schema and then play around, run some queries, if you want to get some practice reps before you actually start building an application. So, when in a lot of the collateral we claim you can get started in 5 minutes, in this case, it is true. We in fact stand behind that. The second thing I want to highlight is the web console. This is a built-in client for to run your application, build your application. And this, typically you have a client that are running on your machine, you have to connect and all that. In this case, we embedded that web client into the cloud portal itself so that you don't have to install, manage the client and all that. And the functionality that console provides is similar to any full standard pSQL client. So you can do all of the things. All of the supported database operations you'll be able to perform in the client. Now the thing is, there is also additional things beyond the command line interface. There is the you see a couple of panes in the bottom. One is the output pane, where if you run a query, you immediately get response back, because a lot of the application development is a iterative process where developers run something, look for it, fine tune the queries and do like that. So all of that is possible without moving off of one screen. You can just stay on the screen. You can fine tune the queries and look at output result. There's some basic charting capabilities also included in the product. And then finally, at the bottom, we have the log pane, where you get information about the errors, warnings, whatever our success of the command of the operation. All of that is available right there, so that from an observability perspective, you get all of that in one pane. And then the last one I want to highlight on the feature area side is the cloud portal. This of the service, so to speak. So it kind of encapsulates all of the admin functionality in terms of how to manage clusters, how to start, basic health checks to see how the service is performing, what is the utilization of resources, and what sort of users and what access they have, and also look at the schema of what's on the database. So all of that information is again in this cloud portal pane, screen that we have built in one place. And then we also have a notification center at the top that gives you information of the key events that are happening, so that the user gets notified if something changed. So that it's a push notification service at the very top. So I know I went very fast with the feature areas, because if when I do the demo, I'm going to quickly show some of the details later. Let me talk about the RisingWave journey itself, like as a company, how far we have come. And I in the intro, I mentioned about important milestones we crossed. So I want to cover that in the next 2 slides. So for those who are not familiar with our story, as a company, we started a couple of years back in Jan of 2021 by our founder, Xiangyu. We are headquartered in San Francisco, although we are totally a distributed team across the world, but our head office is in San Francisco. The goal that Xiangyu had was to build a modern a streaming database for a modern real-time applications. Because there are different ways of approaching this problem, but what Xiangyu because he's a database researcher, he found that the best way to build applications is still using SQL as the database, as the language of choice, because you have a strong developer base. Use that as a springboard, but at the same time, the underlying database cannot be built for batch workloads. So have the best of what in the traditional databases provide, with the underlying architecture that supports the unique requirements of real-time application. That's how that's kind of the genesis of our product as it came together. The founding team has a lot of group of experienced database researchers, practitioners who have built systems at other places. So we have a solid team, and we've grown to up to 50 plus people. And like I said, we are a distributed team across different time zones. So in terms of the key milestones, we launched in 2021, April of last year, 1 year back. We released our open source software, RisingWave as an open source software. And then in the fall, we announced our Series A funding. And shortly thereafter, we announced our private preview of the RisingWave Cloud service. And now, fast forward to April, last week, we announced the beta version. I want to spend a minute on the guiding principles, right? For us, at the end of the day, RisingWave Cloud is nothing but the underlying database. That is the core of our product. And what are the guiding principles we have for that apply across the board for the company in terms of whatever we build. So one of the key things we have is simplicity is a core principle. And whatever we do, make sure that you're not transferring the burden of complexity and technology to the user. Keep it in so that the solution you build is simple to use. The second thing is cost efficient. The architecture that we have picked is all about elastic scalability, about making sure the TCO, in terms of price performance, is very attractive for users. Because at the end of the day, even if you provide the best technology, but if it's not cost efficient, it's not going to be useful for anyone. Third is community, right? We're a firm believer that although developers don't buy enterprise products, companies buy enterprise products, but developers are who are the end users finally, and always keep their needs in mind. And the licensing model to try the product, all that should be to have the innovation in the community, so that it comes from in a way, the way we see community as partners, not just customers who are paying for it, but they have a important say in how we develop product, how we evolve as a company. And the last thing is, one of the things one of the guiding principle is open extensibility, like how we want to integrate with everybody. We don't want to have a proprietary formats, our own way of doing things. We want to be open to partner with anybody, because at the end of the day, we believe that the best of the breed will succeed at the end. And by keeping it open, if people see the need that RisingWave has true value, we will succeed. We don't have to create some artificial way to stickiness in our product. By keeping it open, we are open to partnering with anyone, any other system. And in any case, data systems right now are so diverse. So many different, systems have to come together. So it's almost like a requirement that extensibility is part of the design. And then in terms of our market focus, like where we are, because at the end of the day, as a startup, we have to have hyper focused on a certain aspect. And in our case, we want to be careful that we don't try to target multiple areas. Like if you see general data space, if you plot it in terms of different workloads, in terms of latency, this is one way to look at it. It's going from sub-second to hours and days. There's different types of workloads. Some are real time, some are interactive, non-interactive batch. The current market focus and traditionally has been all of them actually. But one area that's emerging, that's new, is where how can you query on event data, discrete event data that's coming in, and you don't, one of the ways market has tried to address is through micro batch and other ways, but it's still not the same as real-time streaming, and that's what we are focused on. For RisingWave, the focus is provide a solution that is SQL based and that allows a user to query on discrete event data, so that every event has intrinsic value, and that is time sensitive and has shelf life. And how can we get value out of it? That's the core value proposition that we're trying to offer. Let me spend a couple of minutes on our community, because community is an important part of our RisingWave Lab story. And as I mentioned before, our founder Injun is a firm believer in the power of open source development. And we do all of our, for the core product, development act in the open source. We have active community, and we have dozens of customers who are using building applications using RisingWave. It's a fact that and you can see in our community how active it is. So obviously, our commitment to open source is reflected in our growth story. And as you can see, as I said, we are celebrating our first anniversary of launching RisingWave community, and we made a lot of progress. We've come a long way, and thanks to our fearless leader Giovanna, who's always enthusiastic, and is easy to is the best community manager in the industry. And here are a few numbers I want to share, and these are obviously, I don't know if it's current, but they may even be more. So from a GitHub perspective, we have more than 4,050 stars, and our product has been forked more than 350 times. We have an active, thriving Slack community. I think the last count, probably even more than 716, more people are there. And then we have a events calendar that's full. Part of the streaming stories is something we launched a couple of months back. Virtual meetups, in-person events, we've been having all. And finally, we have a newsletter, which is pretty active, monthly newsletter. We have more than 2,000, even more active subscribers. So in a way, we feel like in 1 year, we have come a long way. And it's not just about us, it's about the community and having a larger objective of pushing stream processing to the mainstream. That's kind of the goal. So if you are interested in participating in our community, our commitment is there so that we want to be transparent and collaborative. So if you are an early adopter, go ahead, unload, install our product in your environment, give it a test drive, give us the feedback. If you are the developer kind who are a tinkerer, who want to fix defects, write tests, or basically give us feedback from a developer perspective, feel free to join us and be a contributor. And we have all sorts of resources from onboarding, community support, sharing knowledge, learning and growing together. All of those are part of the community. We are active on our Slack, active on Twitter, LinkedIn. There are multiple ways to reach us. And RisingWave.dev is kind of our developer side of the portal. So with that, let me turn it over to Samuel to do the technical deep dive. I'll push the slides along, Samuel, and you can tell me when you're ready. Okay.
Okay. Thank you, Rayees, for the thorough introduction of RisingWave Cloud and RisingWave product. So I'd like to dive deeper, slightly deeper into the RisingWave Cloud platform and also RisingWave itself's cloud native design in this session. So as Rayees also mentioned, from the first day, we decided to re-innovate the streaming processing in a SQL fashion, also in the database architecture. But unlike the traditional database architecture, which is normally monolithic and focused on on-prem deployment, which is it has limited scalability and flexibility, we decided to have a cloud-first design and cloud-native approach from the first day and from the ground up, which is modular. So we divide all the components into different and distributed processes. And also we leveraged the cloud resources, the IaaS technologies from the first day, which greatly improved scalability and flexibility, and also reduced a lot of cost. So with that architecture, it is not easy for us to move this RisingWave open core onto the cloud. So basically it spent less than a year because all of the efforts that we have pre-designed and pre-implemented on the database side. Moving on, please, Rayees. Okay, so when we first the reason we decided to implement distributed and cloud native architecture of RisingWave database is established on our experiments and investigations on the compute and the storage nature from the cloud perspective. So it has been, for example, from the compute side, the Kubernetes has been the de facto standard of how you schedule and how you place the compute resources on the cloud. So we decided to pivot into Kubernetes instead of using VMs directly mostly because of the ecosystem and the simplicity, and also not reinventing the wheel. So, for example, in one of my previous experiences, if we have to deploy and build a distributed system and platform on vanilla virtual machines, we have to decide, for example, how to come up with the complex policies of the budgets of the virtual machines, how many virtual machines you have to preserve, and what is the overbooking ratios, and how to consider, for example, how about maintenance, DevOps, and also how you do clustering, topology, resource isolation, service discoveries, all kinds of like complicated stuff. But Kubernetes actually take all of that into consideration, and after years of implementation and engineering process, it's been much easier for us to do that. So for us, several features from Kubernetes are the key design factors that we choose. One of them is the unified interfaces from both local development to multi-cloud solutions. So we actually have what we call is a one box, which is a totally local development environment, but we use that for development and testings because it actually has the same abstraction layer of the cloud resources, called one box. And also Kubernetes provides this abstraction for the multi-cloud architecture. So no matter we want to go with AWS or GCP or Azure, all of them have this simplified and the same abstraction of the Kubernetes cluster. And each of them also provide different choices how to like simplify your architecture, or you provide like serverless computing platforms. So this is also one benefit. And also the declarative API for clustering and infrastructure makes it much easier for us to do scaling and also to do the placement policies. Okay, so and also the Kubernetes ecosystem like KEDA, HPA, VPA, all of those, and also the telemetry services makes it much easier for us to bootstrap a PaaS database platform from ground up. Next page, please. So after we choose Kubernetes as the foundation of this compute engine and compute platform, we also decided to make our own streaming engine, totally stateless and like simple services, and also all of the concepts inside RisingWave streaming engine, like the actors, which is one simple unit of the streaming job. Also, they are also stateless, so that we have this hierarchy of multi-level scheduling policies and placement policies available for different layers. From the bottom up, we have infrastructure, and we have the Kubernetes pods, and on top of that, we have RisingWave compute nodes, compute node pods, and also the streaming jobs, which are basically materialized views, and also a simple unit of the parallelism, which is an actor. So all of them are stateless and can be placed on its own individual level. Kubernetes also provides its simplicity for this kind of concept, especially the stateless services. For example, Kubernetes deployment, which is a concept from Kubernetes, actually just fits into this simplified model. But we decided to use Kubernetes stateful set because it has this guarantee to provide this storage fence when you do HA, when you want to fail over a pod into another pod, to avoid some contentions when there is a conflict when you try to like get access to the same states. And also each pod, which is basically a single service of compute node or a meta node or like the compact node in our system, is assigned with an internal IP when they are created. And that makes the service discovery much easier, and also makes, for example, when we want to upgrade a RisingWave database, or we want to pause and resume a RisingWave database, or even we want to do manual scaling or auto scaling of a RisingWave database, much easier. And also putting everything together, we used to have this Kubernetes config map for all of the database configurations. But now, I think from the latest version of 0.17 of RisingWave, we started to work on the backward compatibility. So instead of a config map, we right now also use environment variables to simplify this process. And also, well, in order to achieve the granular resource control, we also leverage workload resource groups so that we can place, for example, different services of the meta nodes or different services of compute nodes into different AZs to make it like highly available. And also we heavily leverage, for example, the existing telemetry ecosystem like Prometheus and Grafana to make all of the stack, including Kubernetes infrastructure and RisingWave itself, the whole stack, like observable, and help us to do all kinds of the troubleshooting works. Next page, please. Yeah. And also, not only compute, we also rethink the storage from the cloud native architecture as well. So we all know that most of the cloud platforms, cloud vendors, they provide different concepts of storage. We have tiered storage like in-memory storage, local SSDs, and also the remote object storages. In order to achieve the best cost performance ratio, we decided to implement the tiered storage from the first day. So the RisingWave itself is the storage, which we'll call Hammock, is also a tiered storage with this LSM architecture. So it is, there are some design that we made to build this tiered storage. One of them is focused on state IO, which is, for example, you have streaming jobs, you have streaming joins, you have streaming aggregations. All of them require, most of them are like point lookups and batch insert. So LSM architecture here just fits pretty much well. And also we leverage, we had a lot of IO optimizations regarding to object storage, for example, multi-part and streaming upload and download optimizations, because when you do a flush and when you do the compaction jobs, you will have a very high requirement of the throughput. So this is where we came up with. And also regarding to the internal of the storage, one of the most important performance would be like performance impactors would come from the compaction services. And in order to optimize compaction services, we also leverage the disaggregation architecture for the compactor services themselves. So the compaction will be also divided into the compute bound services and also the IO bound services. And also both of them are disaggregated from each other. And the compactor nodes are also remotely deployed alongside the compute nodes to reduce the impact of the streaming jobs and also the batch jobs. Okay, next page, please. So the other benefit of the cloud is that it provides this possibility to optimize the cost. And one of the things we all know, for example, there are services like Lambda and also Spot instances. So here, if you're using RisingWave Cloud, the compactors, the compaction jobs are actually running on the Spot instances, which are much less, much cheaper than the regular, the general machine, the general machines like the EC2 machines. So what we do actually is for each of the compactors, we have a lot of metrics. For example, how many compaction tasks and how many like running and how many of them are pending. And also what is the throughput of the compaction task, what are the data sizes, and how then we have this calculation, and we can come up with like what should be the number of the compactor pods, and also what is the SKU that each one of them should require. So we have this service in the cloud called Orchestrator. We monitor all of them, And then we, through the Kubernetes declarative API, we can just modify the spec of the compactor pods. And then in order to define the mapping rules between the compactor pods and also the infrastructure, we leverage the taint and tolerations policies of the Kubernetes itself, so that only compactor nodes can run on the spot instances, and whether how many of the spot instances and what is the size of them is also defined and calculated by ourselves. So from these approaches, we actually implement something like a serverless compaction in the RisingWave Cloud right now. And other than these fundamental like database, the data plane architecture, we also have a broader technology and services running out there to serve the whole RisingWave Cloud services. So we have the portal, and we highly leverage Terraform for all the infrastructure management, and we're also going to provide the Terraform module for the RisingWave Cloud itself. And also all of the control plane is based on the microservice architecture, which are multi-region and multi-cloud available. And also we're right now also work on the billing services, and also GCP services, and also the whole like other much more security enhancement as well. So yeah. So next I'm going to introduce some use cases from our engagement with the customers and RisingWave users. So normally they will fall into several categories, and here we have typical use cases like metrics, especially IoT metrics, anomaly detection. For example, one of our database users, they have like 20,000 machines out there running, and they need to figure out what is the TCP metrics, what is the drop rates of the packets, and also the throughput, and also the device CPU and the storage itself. So all of those kind of metrics are emitted to a Kafka service, and they use RisingWave to do the QoS calculation, monitoring, and alerting. And also a typical use case of RisingWave is a recommender system. So usually it can be used into the feature engineering. For example, there are different events coming in, and you want to do real-time feature calculation, and then you want to use RisingWave at the feature store to fit that into a recommender system. It's also a typical use case. The third one would be some online serving. For example, if you if you want to do some streaming ingestion and do some analytics, and then you want to do some serving for the website or other online services, you need multiple components for that purposes. You need to have a dedicated streaming processing cluster, and also you need to sync the data to a serving database for that purpose. But with RisingWave, it can simplify that greatly.
Samuel, in the interest of time, can we jump to the demo? Because I feel like we have 12 minutes, so it might be better if we do that.
Sure.
So
sure, okay.
I'm going to stop sharing, and then you can do the demo directly, because I think it might be better to go there directly.
Okay, yeah, I can do that.
Yeah.
Okay, so let me share this demo first. A second. So this demo is going to be about this is actually a very simple project, but a very interesting one that I built in one weekend. So we all know that Hacker News is a very popular website among the developers and in the technical area. So so what I did was we want to streamline the Hacker News feeds with some popular technology right now, which are Hugging Face and GPT, large language model, things like that. So we want to have this project to demonstrate how we can combine all of those trending technologies like AI, machine learning, models, Hugging Face, transformers, and also the advanced streaming technologies, the streaming databases, all of those kind of concepts. We want to bring them together and to prove nowadays it has been much easier to build a modern application within just, for example, two nights. Okay, so what I did was I'm going to show this. So basically, we have this Hack and Use API. You can either pull it or like implement some push mechanism to real-time fetch and capture this new post. And you want to use some scripters to and use Hugging Face models to do article summarization and key phrases extraction. And you want to streamline that process by throwing the events into a message queue, which here I use Confluent Cloud Kafka. And also, then after that, everything can be handled by RisingWave Databases from a RisingWave Cloud. It can support streaming ingestion and real-time processing and real-time streaming analytics. And then instead of using dedicated PostgreSQL, here we can just use RisingWave itself to implement the MVC model usually existing in the web backend instead of using Postgres, because RisingWave itself is totally Postgres compatible. So let me unshare and share my screen here. So 1 second. So this is actually the website of this demo, and as you can see, the latest news is 9:51, and I think the latest post was just posted like within a minute ago. And here is actually the dashboard of the streaming analytics, which does a continuous aggregation based on the 5 minutes time window. And so 1 second. So Rayees, you want to still do the introduction of the cloud, or I can just jump into that?
Yeah, let's just jump into it because we don't have time. So I figured that's why I figured you can just jump into the application now.
Cool. Okay, so this is actually the latest look of our RisingWave beta version, which is decent and actually pretty cool. And one of the best features, as Rayees mentioned, was the web console. So instead of using a pSQL shell command or like other SQL editors, you can just using the web-based one, which is totally convenient. So here in my RisingWave Cloud environment, I have two RisingWave clusters. One of them is this one I'm demonstrating here. So as you can see, there are many metrics, and right now it's using 40% of the free tier CPU, which is very low. It has a very low workload, and I've defined a few materialized jobs here, which you can see. It's actually the graph of the DAG of the streaming plans. So let me just jump into the web console to see how we could support this. Okay, so as mentioned in my diagram before, RisingWave is especially useful when you want to do streaming ingestion, streaming analytics, and serving in the single database fashion. So to implement this application, we actually can break that also into 3 steps. The first one is that you want to connect to the data source aforementioned, which is Confluent Cloud Kafka. So after all the events were pumped into the Confluent Kafka, we can actually connect to it using this SQL, which is right now we call them also create table, which is actually a create source. So we connect to this Kafka topic, and then we define the schema. So RisingWave supports RisingWave has a rich support of data types, just like Postgres. Even with arrays and nested arrays, and also JSON as well. So after when you connect to data source, you also want to query from the data source. For example, you want to see whether the data source is working or not, or the schema is the thing that you want or not. So if you're not using RisingWave and using other streaming platforms like Flink, Samza, or Stone, you have to sync the data to an external sync for that purpose. And if it is wrong, you have to go over and do that things all over again. But with RisingWave in a database fashion, you can just write the command to connect to it and then query from the on-fly data. And then you can see, okay, so the data is working, And also you can see that it also should be the latest time. And after you debug all of the data sources in a very easy fashion, and then you want to define your streaming jobs. And here we use materialized views for that concept. And usually this is the most complicated part. It should be like tens of hundreds of lines of code. And I think you can imagine if you're using other streaming platforms, it is extremely hard to debug and write the SQL well. But here we can just also, like Postgres databases, you can start with some simple queries. For example, you can just extract this CTE out from this complex SQL query and see if it works well. And if it is, you can just embed it into a larger one and then come up with the whole full picture. So in my streaming job here, it actually defines a streaming job that does time window aggregations, and also defines and also come up with another materialized view that always project the latest window of that. And so that when you do the serving, it will be like point queries, simplified point queries that you can just query from the latest one. So, and this is actually all you need when you implement this web backend. So you don't need to write some OLAP queries or other complex queries. You can just do a select star from, something simple like that to do the point lookup. So yeah, for example, here, this is actually the result of the word map that displayed here. It's very simple and it's very high performant, low latent, because we have this multi-layer tiered implementation and also cache implementation. So, okay. So I think this is the demo, and I think that's all I have today.
All right, thank you, Sam. Let's see if there are any questions that have come up. I haven't had a chance to look at the chat window. Yeah, so I don't see, I see one question about beta support. I think I addressed that question, so it's okay. If there's any other questions, let us know. Otherwise, we have a couple of minutes and we can finish early, a couple of minutes early. So, all right, I really want to thank everyone, and thank you, Sam, for the nice technical deep dive and also the cool demo. We'll be sharing the slides and the link to the presentation to everyone. Thank you, everyone.
Thank you.